Hello everyone and welcome in the React Native Show podcast. In today's episode, I'm excited to talk about virtual reality, extended reality and augmented reality. And can we run React Native in those realities? Who knows? I hope my guests will know. My guests today are Michał Pierzchała and Oskar Kwaśniewski. Hi guys, how are you?
Hey Łukasz.
Hi Łukasz.
Hi Oskar. So maybe let's start from you because you are the main guest for today's podcast. You are the author and main maintainer right now for React Native for visionOS. So please tell us some more about yourself and about this small project that you've been working on for the past few months.
Sure. I'm a senior React Native developer at ColdStack. I'm an open source maintainer, and I'm working on this initiative of bringing React Native to visionOS for the past few months.
Okay. And Michał, what is your role at ColdStack and what the hell do you have to do with React Native visionOS?
So I'm a head of technology, which means I'm running our open source and R&D/innovation initiatives, and XR and Apple Vision Pro is something that we are recently interested in exploring. So we've just put it on our R&D radar.
Okay, awesome. And so let's start maybe with some facts. So you said, Michał, Apple Vision Pro. Is that the right name for this device?
Yeah.
Okay, so that was announced a few months ago on WWDC conference, right, by Apple. So
Right.
It means that Apple is entering this space of extended reality, virtual reality, augmented reality, whatever you want to call it. And we will try to answer the question about the differences between the different versions of the reality. And this market is not new. This is not a new niche. This product is entering a market that already has some big players in it, that already has some customers, already has some devices on the market. So from history, it would seem that this is a very Apple strategy to do that. iPhone wasn't the first phone. When iPhone came out in 2007, we already had Nokia, BlackBerry, and all of that devices, very popular. But when Apple came to the market, it quickly, and let me look at my graph here. So iPhone was introduced in 2007. By 2011, it had 18% of the market, which is huge, right?
Yeah, a lot.
The market overall grew, and Apple share on that market stayed relatively the same. It still has around 18% of the market share of phones with iPhone devices.
Yeah, which means that it's actually growing because the smartphone mobile usage is growing globally.
Yeah. So with this new device, with this new category, they could try the same scenario and achieve the similar result. So when Apple enters some market, that the market will grow and Apple will take significant chunk of that market. That was shown previously. So we definitely hope for that because right now the VR XR market is not really that big in terms of customer products, in terms of like computing products. It's not comparable to phones, that's for sure, right?
Yeah, for sure. And I think it's also important to mention that when iPhone was introduced, people were saying like, where's the keyboard? Because this device didn't have a keyboard. And I can see the same pattern now, that people are saying that this device won't be the future, just like they were saying when the iPhone was released.
So
yeah, and
maybe
also about like iPhone and the keyboard thing, there is a really cool movie that was released recently about BlackBerry I don't know the actual name. Let's say it's some BlackBerry movie from 2023. I really encourage you to check it. There is a nice progression in this on how Apple approach things versus keyboard BlackBerry. And
I think it's called BlackBerry. I just searched for it. It's called BlackBerry. Okay, back to the topic. So I took a liberty of comparing the phone market from 2007 to virtual reality market from today. So Michał, can you please explain to me what are the players on that market today, like we had Nokia and BlackBerry in 2007?
So we have Meta, we have Sony, we have HTC, and also like Valve, I think entered the market as well. There is Samsung with their Gear VR that's not really in production, and there's also Google. I'm pretty sure all of us tried Google Cardboard at some point, like 15 years ago or so. I remember strapping my touch Nokia actually into the Google Cardboard. So it was actually very fun at that point. And it costs like, I don't know, $20 or $40 or so. Everybody got that. It was fun, and also Nintendo is in a similar space as a Cardboard. Anything that I missed, Oskar, maybe, or?
I think you missed also the company behind TikTok, which is ByteDance, which also has its own headset.
Yeah.
And yeah, so, I think that's pretty much it.
Yeah, but
the players.
The main takeaway from this is that we have a bunch of different companies competing in this space, shipping their product. They already have customers. Not really a bunch of devices shipped, nothing to compare to phone market. And the price points for those devices are also very different. But when Apple came with their, is it $3,000 device?
Three and a half.
Three and a half. So yeah, they blew everyone from the stage. So so that's the market for the manufacturers, right? What's up with the division between augmented, extended, and virtual reality?
Okay, yeah, so I can take this one. So there are a lot of short terms for it, but like virtual reality, which is VR, it creates a fully immersive experience for the users. So they are like in the real world exploring. They have no connection with the outside world. AR is like, for example, on smartphones, when we see through the smartphone camera some 3D elements. This is AR. And also XR or MR, which stands for mixed reality. It is a term that encompasses both VR and AR, and it stands for extended reality, which is what actually Apple Vision Pro supports. So it can fully immerse us, and also like immerse us in 20% or 50%, so we can control the level of immersion that we have, and the virtual elements interact with our surroundings. So yeah, I think I've described it pretty well.
Yes, I think you did. So maybe on the topic on Apple Vision Pro, what is this device capable of? What can I do with this extended reality device?
Yeah, so as I said, Apple Vision Pro is an XR device, so it blends the digital content with the physical space that you have, and it does that through cameras. So it's actually a projection of what you see, it's not like a full pass-through, but the Vision Pro cameras capture the world around you and overlay the 3D content. And so the navigation is something that we could divide other headsets for. So Apple Vision Pro doesn't have any external device that you can use to navigate.
No keyboard.
No keyboard, no controllers, joysticks, whatever. You just use your hands and voice and your eyes. So it has this screen has more than 4K TV for each eye. It has like a spatial audio speakers, some advanced eye tracking, and what's pretty cool, it has an M2 chip, the same that you can find in like a MacBook Pro.
Okay, M2 chip, yeah. So I have a thought in my head that we just spent, I don't know, maybe 10 minutes talking about extended reality, Apple, other manufacturers, and it might seem like we are doing the Apple Vision Pro commercial, but this is the React Native Show podcast, and we will get to React Native, believe me. Just one last point on the device itself, and then we will get to the React Native part. So that's the physical part of the device, right? You mentioned. What is the software part of development for Apple Vision OS system?
Yeah, so Apple Vision Pro ships with visionOS as an operating system, and this operating system will be used for future devices. And it offers you a way to render 3D elements. It has, like, for now we had Windows, for example, in desktop applications, but visionOS expands on that topic and allows you to create volumes, which are windows rendering 3D content. And also the visionOS allows you to render spaces. And by default, when we launch our app, it boots you into a shared space where every app has its own chunk of this space, and apps can control the level of immersion, allowing developers, for example, to set the immersion to full immersion, so it would be fully immersive space. And yeah, visionOS focuses on Swift and Swift UI.
So sorry, maybe sticking with like the, let's say, development modes. You said there are 3: Windows, which we already have in just regular mobile or desktop apps, volumes and spaces. So volumes and spaces are new, Windows are old. Does that mean that I can just take my application that I developed for React Native or for macOS, and I can just run it on visionOS Pro with probably some tweaks, but it will still work? I will see a window somewhere in my living room, and I would just interact with that window with that macOS app?
Yeah, pretty much. You can say that. If you take an existing UI kit app, which React Native bases on, you can recompile it to work on Apple Vision Pro without almost any issues, as we will discuss later.
Okay. What's the situation with controls then? With interaction with that window? So on phone, I have touch. On my desktop, I have my pointer and keyboard. How do I interact with that window or with that space or with that volume using just my hands and whatever else?
Yeah, so I think an important disclaimer here is that I've never actually used the device. I was only developing on the simulator. But from what I know from the documentation, users, the OS highlights where users look. So for example, if there is a touchable button, it will get highlighted when we look at it. And when we press like this with our fingers, the element will be selected. So this would be the equivalent of clicking. And if the window is closer to us, we can actually reach for it and click with our, like you would on a tablet or something. So,
and this is handled by system layer. So the gestures and pinches and eye tracking is handled by system, and developer is only exposed to some API that we can interact with, but we don't have an access to like actual hand tracking. We don't have to care about that.
In normal apps, we don't. I know in Reality Kit, I think you can track users' hands to display something on it. But like for normal apps, you don't need to care about it. Every gesture gets translated to something that we had before. So yeah, it will be just a click for us in the app.
Okay, thanks so much. And sorry for putting you on the spot here. I know that you are not a visionOS developer per se who already played with the device, but I'm just really, really curious because this is something that native platform exposes and that you as React Native developer have to bridge to React Native somehow so that regular JavaScript developers can use it at the end of the road.
Like it's mostly translated on the UI kit layer. So on the Apple framework side, we don't need to think about it. Like when we have a native app and we want to recompile it for visionOS, those gestures will also get translated. And like it would, for example, if we, do 2-finger gesture, on visionOS, it would be 2-hand gesture. So the only thing that we need to remember about is that when we have, like, for example, 3-finger swipe, it wouldn't work for visionOS because the maximum input is 2 hands. So yeah, we can only do like two inputs at the same time.
Yeah,
gestures.
It's also translated to the simulator space. So you can actually click, like what you see is translated to the mouse hovering over some elements, for example. There is a transition layer to, I guess, all or almost all of the interactions there. And Apple's visionOS simulator does a really, really good job at like interacting with this space by having a 2D screen inside of you. Because so far, I think Apple only started or is about to start delivering the actual dev kits. So we're not able to test it in production yet. We're on a wait list. Waiting for actual device, and we're expecting the first device will come to us to Wrocław, and then will be transported to Szczecin where Oskar is. So I guess that'll be fun. And other than that, there's only a handful of Apple app stores or Apple stores, physical stores. That exhibit the device, so you can try it yourself. And yeah, every time I've been in US this year, I was just so occupied with everything else that I forgot it's possible. And it was like on a store on the next street nearby. So yeah, I need to try it next time.
Yeah, definitely. And this is also so much cutting edge, right? They announced it a few months ago. They have not shipped any developer kits yet. People are creating some new, probably native apps for it, but we, as the first ever company in the world, to my knowledge, we are porting React Native to that platform. And this is not news, probably because the version is already public on our GitHub repository. So let's maybe talk about that. This is a React Native show after all. Oskar.
So maybe like one disclaimer. So maybe we are the first company to like invest in this space for React Native. But there were some attempts from individual contributors like Daniel from Expo, I think.
Gabriel.
He was trying. How is he?
Gabriel.
Yeah. Gabriel, sorry about that. Hope you can forgive me. So he's done a lot of cool groundwork for that, and also in the CocoaPod space, So we're like we've started from slightly different angle with a vision of having like a fully fledged platform that's easy to integrate for any other React Native project, or if you want to start with just visionOS projects. So we have this developer experience and not hacky solutions in mind from the very first day. And this is all possible thanks to our cooperation with Matt Hargett from Rebecca Specialties, who we collaborate on this effort to ship one of the first apps for the Apple Vision Pro store.
Yeah, so I think we can say we are like the first company to release React Native visionOS, because there were previous attempts, but none of them were actually released.
Okay, so guys, can you please tell me and our listeners, what is React Native visionOS?
Sure. So it is an out-of-tree platform. And you might ask, what is an out-of-tree platform? Because that's not obvious. So currently we have, I think, 3 of them, but most probably there are more. So we have tvOS, which ships for Apple TV and Android TV. We have macOS and we have Windows. And those are basically forks of the React Native core repository that put some if statements and some additional things to make it work for that platform. So the way we did it, we used something like compiler conditionals, which allowed us to actually compile not supported code from React Native core for visionOS. Actually, not compile. The compiler conditionals exclude something from compiling. And yeah, I think that's explanation of out-of-tree platforms. Maybe anyone wants to add something?
I just want to summarize and ask you if I understand correctly. So I fork React Native core. I name it React Native Platform X. And then I add some additional bits and pieces to it so that my platform compiles properly.
Yeah. Oh, pretty much, yeah.
Yeah, and now you can name yourself an out-of-tree platform.
Out-of-tree platform developer.
Yeah. I have no idea where this came from, but that's the naming that maybe Windows started, or PlayStation at some point where they were working on their thing. So, yeah.
Well, I guess the reasoning, right? The reasoning is correct. We have a core React Native that targets mobiles mostly, and the most community is gathered around mobile. And then we have macOS, Windows, visionOS, tvOS, this like different out-of-tree platforms that have some community around them and that have dedicated people working on those repositories, but not necessarily useful for most of React Native community.
Yeah, exactly. These are like, let's say, niche use cases today. They don't have to be niche all the time. And, we are JavaScript developers. We want JavaScript to run everywhere. And we were just pushing on that vision using React because it's a great UI library to make it happen. So yeah.
Okay. So let's go with our episode, and let's talk about the use cases for this. What are the use cases for creating a fork of React Native that targets visionOS? What can I accomplish with my React Native app on visionOS platform?
Yeah, actually, I wanted to add one more thing because I think it's pretty important to add it. As on the day one of release of visionOS SDK, everyone was compiling their app in something called compatibility mode. So you could say that React Native is working on visionOS on day one. But I think it's pretty important to explain what actually compatibility mode is. So it is a way of basically retargeting your iOS app to visionOS without the full SDK support. So that kind of app could just render the UI without, for example, allowing you to use Reality Kit or use volumes and immersive spaces and all of that good stuff that you get for visionOS. So yeah, that's why on day one we had a lot of people showing that React Native is working, but it was working in the compatibility mode layer.
Yeah.
So yeah, let's go on with the use cases.
Yeah. So thanks for talking about the accessibility mode. Compatibility mode. So what are the use cases for my new React Native project that targets visionOS?
So first thing would be that we bring React to like yet another platform, and through that we like to think about it as opening the space for and hopefully an explosion of ideas and creativity and innovation in this space. So we want to enable that. At Cossack, we have this vision of React Universe where we can run React virtually everywhere, and visionOS, because it's so similar to iOS. It was actually a low entry barrier to put React Native there, and we just jumped on it. So by this work,
let's see if Oskar agrees with that statement.
I mean, yeah, relatively, yeah. So yeah. If you look at our fork, it's around like 1,000 or 2,000 lines of changes. So in terms of like how much extra code needed to be added to React Native core, it's not that much, but it required a lot of groundwork, researching, and probably there is like 10 times more time poured into thinking and reading documentation and trying to oversee different integration between different libraries in the ecosystem before you actually write a single line of code. And then it may actually happen that someone from the core team will tell you, hey, we have a different way to do it, so let's do it differently. So this is this kind of weird situation we're in. What else?
I just want to point that out. First reason, because we can.
yeah, exactly. It's like it's possible, and why not, right? Thankfully, we can afford doing it, and we have Oskar, who had all the necessary skills to just make a bold move. So yeah, we just did it. Another thing is that this enables new and like enhanced data visualization possibilities. Like, imagine immersive spaces, new user experience where you can visualize big data sets as a single person instead of like scrubbing through the 2D spreadsheets or Xcolor drawers, TL drawers, all those diagrams, and imagine having them like at once around your head. This is closer to how a lot of people think about problems, and this, by making it very visual, will possibly allow engineers or architects or like anyone who has to deal with large data sets to have way easier time, maybe enable them to actually see patterns somewhere that they wouldn't perceive it anyway. So this is like completely new thing that's it's gonna be possible to do with native programming for Apple Vision Pro as well. But with React Native, like writing UI is like 10 times easier and faster than you would do in native space. So like bridging all of those capabilities is like adding enterprise grade application level to and making it available to everyone and just do something with it. So this is very exciting.
I also wanted to touch on this.
I think that will be the biggest cases for us. This is still like very unexplored, very uncertain days for this technology. It may happen that it won't work out, but on the upside, we learn a lot, we've also contributed a lot back to the core, but we'll get to that later.
So I wanted to touch on one use case that I have in my head. So for example, in the native space, you have a Swift app that you are developing, and you click add target, and you now target visionOS, and then you can expand on those features for visionOS. So for example, you can add some immersive spaces, immersive scenes, volumes, etc. But in React Native, that wouldn't be possible without this project. So imagine you have a pretty large code base that you can just add React Native visionOS to, and you can easily target this new platform, same as native developers can. So that's pretty cool that you can do it.
I can imagine that for huge projects that are already very multi-platform, they're on several different TVs, mobiles, web, whatever. Adding this visionOS platform will be much easier with React Native visionOS. The whole logic is already there. Like the bunch of views are already there. You can just port them to the new platform and you're ready to go.
And also Apple sells us Vision Pro as a device like for a home theater. So streaming apps would be pretty cool apps to port to this platform. So you could have a home theater in your XR space. Like
more immersive experience even, because from I've seen some code demos where you could generate like a whole pitch, whole like basketball field from it to the movie or like 2D streaming basically. So this is like completely new ways to present and entertain users, to make things more immersive basically. So we will probably explore the UX of those things for many years to come. Hopefully, if Apple doesn't kill this initiative, which may happen. No. Although, they're not Google, right?
They're not Google.
So moving on, I want to ask question in two parts. So the two parts are, what is the status of this project right now? What kind of features and capabilities I have already in my hand with this initial release? And what do you think needs to get in there, what you already have on your roadmap for the let's say production version, for let's say for it to be a fully fledged out of tree platform for React Native that anyone can just grab and use for their projects?
Yeah, so I can take this one. So currently we support Greenfield. In Greenfield development, we support old and new architecture. So if your existing app is still on old architecture, you will be able to port it to visionOS by still using old architecture. We support Hermes, which I will explain later how we did it, because it was quite a challenge to do it. We've added also the init command, which maybe, Michał, you want to explain on how it works now?
Yeah, so the React Native CLI has this init command that basically copies some important files from the template to your folder. And it's designed in a way to make it work not only with the core iOS and Android project, but also for any other platform. And with visionOS, we're like stress testing this idea, this solution of init, and thanks to that, we apply many different fixes to the edge cases that we discover. So hopefully we will be able to like push those improvements also to other out-of-tree platforms like tvOS, for example, which is set up in a slightly different way than the visionOS, and macOS as well. Windows is like completely different beast. They have a lot of their own, like they have their own init solution. But thanks to that, what we intend to do is to reduce the scope of out-of-tree platform maintainers to fork from the core, basically. So it's about sharing as much of the code and functionality and ideas as possible. And with React Native CLI, like one of our top priorities is to support the out-of-tree and Brownfield integrations. So this is an important integration point that we see between our team and the work that Oskar is doing.
So if anyone wants to start this journey with React Native visionOS right now, what do they have to type in their?
Yeah, so currently it's very similar to how you can init a React Native project. So we can run npx add call stack / React Native visionOS init and the name of the folder, and you're good to go. So this is still like early days of this integration, and there are still changes that we're doing. So treat it as slightly experimental, but the overall developer experience is intended to be as this. So it's as similar to the regular React Native development. And in the near future, we also want to support use cases where if you have existing React Native project with iOS and Android platforms, for example, and you want to add yet another platform in a different folder, we want to allow and make it simple for users to integrate, at least to some extent.
Yeah.
Okay.
So also in the Greenfield development field, we want to add support for third-party libraries. Currently, no libraries support for visionOS, but that will change we have plans to support. So maybe
You
when
told
you're
me
listening,
yesterday that Reanimated was compiling.
yeah. So I was getting into that. It is compiling, but yeah, I just hacked it in an evening to make it work. But yeah, it's not officially supported. But yeah, it will be. So if you are a library maintainer and you want to add support for your library to add to visionOS, reach me out and I can help with that.
Yeah, I think at this point it's usually a matter of adding like one extra line to the pod file to support visionOS targets, and maybe some small changes because the visionOS platform builds on top of iOS. So most of the code out there that's supported on iOS, it's also automatically supported by visionOS. Not everything, but most of it.
Yeah, we will get what's not supported. So yeah, but mostly it's adding one line to pod file, and it depends on how complex your library actually is. And getting to the second way of developing, you can use Brownfield development to extend our generated template with SwiftUI. And in that way, you can create immersive spaces. You can create volumetric windows. So in that case, you can do everything just like in the native world. And in the future, we want to move as many things as possible to the JS side. So like maybe immersive scenes and volumetric windows would be possible to run from JS.
Yeah, this is still something that we haven't designed the API for yet. It's somewhere on our radar. And I want to go back to the Brownfield development for SwiftUI native application. So how are you achieving that in React Native? It's not very obvious because usually we integrate with an Objective-C app or like regular Swift app, and here it's SwiftUI. So would you like to share some small insights on that?
So what we actually want to do is not yet done, but it's on our radar to release it. We want to embed React Native in SwiftUI lifecycle using things like UI hosting controller. It is a native API that allows you to basically embed the UI kit inside of SwiftUI. So that way the root of the application would be SwiftUI, and then further down we would have UI kit as it is now. And that allows us to use visionOS only APIs because most of them are only for SwiftUI.
I mean, it's cool from the SwiftUI creators to create this kind of compatibility mode for UI kit that we could hook into with React Native, right?
Yeah, it's pretty nice, but it's also Apple is pushing everyone to use SwiftUI in that way, which is on one side great, but on the other hand, it's not too good.
I recall some analysis of internal Apple apps. I mean, internal, the ones that ship with iOS, and SwiftUI adoption is like very small. It's around like 3% or something of all apps use SwiftUI. So I think Apple first needs to sort their internal usage, and then maybe people will follow by good practices there.
Guys, I'm gonna stop you here with this amazing discussion about SwiftUI. Maybe this can be its own coffee talk episode or something. So go to Kuba, who is the host of the Coffee Talk by CallStack podcast. Let's focus on visionOS for a little bit more. I want to ask Oskar last question about capabilities and features. So is there any other feature or capability either already existing in the repository or something that you envision needs to be there for it to be production ready that you want to mention?
Yeah. So currently, one of the APIs that we support is hover style. So what it does is it hovers on elements that user is looking on. So visionOS tracks your eyes and it knows that you are looking on a certain element, and we can highlight this element. And it works for all of the touchable components by default. And you can also apply it to your custom elements if you want to design something custom. There are also visionOS-specific APIs that, for example, ship in RealityKit, which is Model 3D. It allows you to render an inline 3D model. And those APIs, we are still discussing whether they should come as core or they should come as a separate package. But we also want to add ornaments, which is API to create toolbars that are flowing around the main window, and also tab bar. So currently in React Native, you can use tab bar from React Navigation, but we want to implement actually a native tab bar because it has a special appearance for visionOS. And of course, as we discussed before, we want to add Swift UI as the root of the application, and also immersive scenes and windows.
Yeah,
When
it's
you
also
say
it's also unclear what to do with gesture handling, right? Because today we're leveraging the JavaScript button responder API, and the native one is from the React Native gesture handler. So we hope that folks from Software Dimension are listening to this podcast, and if you want to hack on gesture handler for visionOS,
So it would be
please
great.
be our guest.
I remember when you prepared to this episode, me and Oskar, we had a discussion about the experimental state of everything that we are discussing right now. That this episode comes with the warning: anything you hear on this podcast might be changed at some point and might not be in the main repository when podcast drops even. So be careful. But more or less, this is what we are presenting to you with the React Native visionOS. I want to go back to something that Michał said like a half an hour ago or something like that. And he said, we did it because it was easy. So I want to ask Oskar about that, and I want to stay here for a little while. Oskar, what is the process of bringing a new platform, even though it is similar to macOS or iOS, to React Native?
Yeah. So like we mentioned before, thanks to the community, there were support for things like CocoaPods, which is the native dependency manager that React Native uses. But it wasn't released yet. So what we did, we were using CocoaPods from the source, from the main repository. And the first thing that you need to do, and it applies only for platforms that base on iOS, we needed to add platform visionOS to every pod spec. So to like every package JSON file. What happens if the pod file is not in your repository? What you can do? So it's something that actually React Native Core is using, and we leverage this. So you can create a folder with pod files that you want to patch, change the version to something weird like that one, or whatever you want, and then you can add the platform, so you can patch the pod file however you want and point it to the original source. And that's what we did first. We added platform visionOS to every third-party pod file and every internal React Native pod file. And it didn't work because we had a lot of errors. So the issue was that APIs that were deprecated, before iOS 16 are not supported on visionOS. And there are a few of them, like notifications, text content menu. And firstly, we just commented them out. But then we needed to get back to this. But let's talk about like the first time we managed to run it. And then the probably worst thing for visionOS in React Native, which is the UI screen API. And it's the API it's the native API that allows you to call into the current screen of your device. And as you can imagine, React visionOS and Apple Vision doesn't have a screen that you can actually access, but it bases on Windows, same like macOS and iPad in the Stage Manager mode. So we refactored every call site of UI screen to use something called UI scene, and we took the current UI scene. So that way we had the access to the UI scene that's currently presented in front of the user. And as React Native heavily depends on this API, we can't add support for multiple windows at this point. But as we said before, we want to expand on this idea and introduce API that would allow you to have multiple screens and multiple instances of React Native running, for example, side by side on visionOS, and also that would bring the multi-window support for iPad. So that's pretty cool that iPad would get this basically for free.
Yes, I think this is something that we will touch on several different challenges that you faced, but by solving visionOS specific issues, specific challenges, you had to create some solutions that are adaptable to other platforms as well, and you had to contribute to a lot of different repositories to make it happen.
Yeah. So, of course, we contributed to React Native. We have a pending contribution to Hermes. I also wanted to update pod files in Cocoa Pods repositories. And, of course, we did an indirect impact on other out-of-tree platforms like macOS. So we merged our fixes to core, and thanks to that, when macOS synced with the upstream repository, they get those fixes. So let me also talk about the unsupported APIs. So not every API can be translated one-to-one for visionOS, as this platform is fundamentally different than others. And so the keyboard, for example, in React Native, we can manage keyboard pretty easily. But in visionOS, it's a floating window, and we can't imperatively control this window.
I think some would argue if you can easily manage keyboard and inputs
on regular React Native, yes.
But let's come back.
I think we already established that the concept of easiness is relative.
Yeah, of course. I hope I said relatively easily. Because, it's definitely not easy. It's a lot of hard work. No, it's just possible.
Yeah. And also, another unsupported API is appearance, which might be weird for you, as Apple introduced dark mode, light mode a few years ago. And for visionOS, it's not supported. When you will query what the actual appearance is, it will return dark mode, but it doesn't have that concept. And what it is, it wants you to adapt to the surroundings. So for example, if you're in a light room with a lot of sunlight going in, then the appearance of the window adapts. And the same goes if you are in like a dark room with the lights turned off. also another few APIs, status bar and input accessory view, which I won't get into, but those are something that won't work on visionOS.
Yeah, the platform is, like you said, fundamentally different. There are different ways to interact with this. So I guess, are those unsupported APIs the things that you mentioned you had to basically comment out?
Yeah, at first we commented it out, and now we give like nice warning that you shouldn't use them, and you should only use them for other platform than visionOS.
Okay. Yeah. So we detect whether we're rendering in a visionOS environment, and for that we actually thought like really hard about whether this is a separate platform or it's something else. And it turned out it's not really a separate platform, as in terms of when you use platform.os equals iOS or Android. If we treated visionOS as a new platform where you could query platform.os equals visionOS, we would lose all the third-party community packages and also internal implementations that only target iOS or assume that you're on iOS. And we want to leverage that because there's like 80-90% of the code that's shared between iOS and visionOS platforms, maybe more. So we were thinking about naming it something differently. We started with coming up with a new concept of a platform variant where we would have iOS platform and visionOS variant. Then we went to the Metro team, which is responsible for resolving different files based on platform extensions, and they said that it may not be a best idea ever, because we would need to introduce new thing to the resolver that's only accessible for those other platforms than Android and iOS. And the second thing is it would possibly create confusion, because our idea was to come up with file extension like scheme where you could name your file .ios, .visionOS, .js, for example, and we could easily see users mixing those two between each other, which wouldn't work, which would provide confusion and some voices that developer experience is shit for React Native, right? So we wanted to contribute this idea to the core. We got a really valuable feedback, and we went back to implementing a custom custom file resolver for our platform only, which lives in the visionOS repository, and that users will have configured in their the Metro configuration. So that was an interesting experience, and one of those things that adding like one small thing may take a few weeks, and eventually we won't write any code in it, or every code that we've written will be scrapped, but the ideas and discussions stays. So I think that's the real value, and Meta and Microsoft also with their extra platforms experience are very keen to share their knowledge, and sometimes it's really pain in the ass when we are contributing something, and to us it's a very small change that wouldn't require a lot of maintenance from their side, and they bring to us their own perspective on that, which is also valid. So there's a lot of discussion.
It has to work within ecosystem, right? We have to think about how the bigger picture works with
Yes.
other platforms
Yes,
as well.
we take that into advantage. Into account first and foremost. But what we also need to think about is the project maintenance. So React Native is really big in terms of its API surface, and the core team, which is also growing bigger. They need to be very mindful of what goes in and what they need to support. If we want to end up in a place where React Native is stable and has stable API, we need to be very cautious about it. So, although it's very painful from our point of view, mine and Oskar's, it's something that's probably very important for the whole project to succeed.
Yeah, I wanted to also add one more thing, that our utility that we've created, basically to remap imports, is also available to use for any other out of 3 platforms. So it's not only tailored to our solution, but other out of 3 platforms like tvOS could also leverage this resolver for Metro. So yeah, let me go to the next challenge, which is
Please.
triggering dev
that was
menu.
one of the biggest.
Yeah, which is triggering dev menu from the device. So currently, when you hit D on your keyboard, it will show up the dev menu where you can reload your Metro bundle and stuff, but we don't have any way of triggering the dev menu from the actual device. And there is no keys that we can access, because there is like a digital crown that users can spin and it adjusts the level of immersion, but it's not something that we can get access to. So yeah, we are looking for ideas. If you have some ideas how to trigger dev menu, for example, I don't know, shake your head to trigger it, let us know.
Yeah.
I hated the shaking of the device previously.
I recently
it was such a pain, especially on large tablets.
Yeah, that I can relate to that. And also, I recently discovered that some things pop out, like I think keyboard or others, if you press and hold Shift, for example, or other keys. So I guess we could leverage some of those hotkeys, at least for that, like regular development. And the actual thing I was referring, that was like probably one of the most challenging and project dependent, was building Hermes, right? Because today visionOS supports Hermes and JSC, but it required a lot of work from Oskar. So share your experience here.
So firstly, for like the first build, we disabled Hermes immediately because it was failing on some C++ error that was pretty hard to debug. So yeah, after we got everything working, I got back to trying to build Hermes into the app. So yeah, when I reached out to other contributors on this topic, we discovered that Hermes also wasn't working for macOS, as Microsoft doesn't support it for React Native macOS currently. They don't use it. So yeah, that was my first observation. And we are talking about local building of Hermes, because as you know, Hermes is shipping as a pre-built package, but I don't want to get into that and how it works. But let's talk about only building local version of Hermes as we do now. So actually what was happening is that we were building Hermes for macOS and trying to link it for visionOS, which obviously isn't going to work. And another thing that was making it harder is that visionOS under the hood, and it was its code name, is named XROS. And Apple is claiming that they've renamed it to visionOS fully, but they didn't. For example, in CMake, it's still XROS and XR Simulator. The same as... Yeah, go ahead. The same as...
Similar to how iOS used to be named iPhone OS.
Yeah.
And today we also... to this day, from 2007 to 16 years, we still reference the code name, project name that was there as a prototype, and it's still there, the code. So, if you're afraid of shipping legacy code, even in when you're shipping your proof of concept or an experimental product, don't be. Apple does it as well, and your legacy code and ideas can last forever for that project scope. So don't worry, don't be too hard on yourselves.
So then I went to building CMake from source to actually check what's going on even deeper, not in Hermes, but in actual build tool. And it turned out that CMake built from source, so it wasn't a released version, was passing a faulty flag, which was always building for the actual device, not the simulator. So that's why when we were trying to build it, it wasn't working. It was saying that it is a version of Hermes built for the XR OS and not XR simulator. So yeah, I've changed few flags inside of Hermes, build it, and yeah, it worked. Now we are just patching our own fork of Hermes until this issue is resolved. And after it will be resolved, we will add official support to Hermes, so you don't need to do any, use any forked versions of Hermes.
Yeah,
and you said that you discovered that it doesn't work for macOS as well. So will it work on React Native macOS with your change as well?
Yeah, so I've actually contributed fixing the local build script, and it made it work for macOS. So yeah, it works now, and they can fully use it.
That's great about open source, right? One seemingly small change can bubble up to all the other projects, and those projects could be React Native for this yet another platform. So I think that's really amazing, and there were a lot of contributions that you made back to the core of React Native and also to other projects, right?
Yeah. So I can share some stats on this day. I'm sure that there will be more, as we are trying to contribute as much as possible and as much as we can. So I've made around 15 PRs to React Native core and also to other repositories that I didn't count. And yeah, as a part of it, I was removing the deprecated APIs in core and adding support, moving closer to adding support for multi-window. So yeah.
Thank you so much. I think we'll be wrapping this episode, maybe not slowly. The last thing that I know Oskar wants to do right now is to thank a bunch of people who helped him along the way with this huge effort. So please go ahead.
Yeah, so I want to thank for everyone who helped us to reach this first release. And it was Ricardo from Meta, Matt Harjet, Sat Naimi from Microsoft, and of course Gabriel, who we mentioned before, and other core contributors and people from CallStack that also helped us. So yeah, thank you so much.
So what's next for this project? What do you envision for this project for the next few months?
Michał, you want to touch on this, or should I go?
What's next? Actually, Apple Vision Pro and visionOS is like the first step on what we want to achieve, and what's actually Matt's idea of bringing React Native to any extended reality devices through the WebXR web API. So one common thing about all the VR headsets out there is that they can all run a web browser, and they can all run JavaScript, and most of them are capable of supporting the WebXR specification. And we see a possibility to, which is like, we still don't know whether it will work, but we see some possibilities to bridge the underlying implementations of the WebXR like facade to the React Native apps through JSI interface directly. So this is the actual end game for this effort. So visionOS is like the first step, and the next one would be bringing React Native to any other VR device. We know that Meta is doing like their own thing internally, which is, I think, based on Android, some flavor of it. So it's a different idea, and we're very much excited about it. We have no idea if we are gonna pursue it that far. For now, we wanna have a working production-ready app released whenever the Apple Vision Pro App Store is released, probably somewhere around March next year. And we also want to make sure that all the good things in like related to quality of software engineering, like CI testing, end-to-end testing, are all there, because it's a different thing when we can hack something on a platform and it's possible, versus it's actually let's say enterprise ready for developers to invest time there, write quality software, make sure there are tools to debug, profile, test, and have like a fully continuous integration cycle built into that. So this is very important, something that we had in mind from the beginning, and we'll see how it goes. We'll definitely spend some time working on it next year, so stay tuned.
Yeah, the repo is public. The first version is released. We are waiting for your input, for your feedback, for your contributions maybe. So go ahead and check it out. It's under callstack space in GitHub. And that's the episode about the React Native visionOS. I'm really proud of it. Thank you guys so much. So today we discussed the extended reality landscape from the perspective of Apple device, Apple Vision Pro, that is coming out in the next few months, and our efforts around bringing React Native to that device and to VR, XR in general. And we spent the most of this episode talking about the challenges and features that Oskar is bringing with React Native visionOS to visionOS operating system. Thank you so much, Michał. Thank you so much, Oskar, for joining me to the show. And thank you so much, listeners. Go ahead and check the repository. Thank you.
Thank you, Łukasz. Always a pleasure when you're hosting. Thanks.
Thank you. Bye.
Bye-bye.